start to go through already. After all, it's like a homework kind of question, right? All right, anyway, there are two things difficult about this question. All right, one is the fact that you have three sets, which is a three circle, what we call the Mickey Mouse shape on day one, the lesson one we talk about it, which is actually the part 2, okay, something like this. So you need to, first of all, deal with the Mickey Mouse, which is before 2015, all the students probably haven't dealt with it many times, probably never before as well, okay, because in the secondary school days, you don't deal with sets with three circles, and then in A-level, you also don't really learn sets at all. So it becomes a new, so-called new things, and that was scary by its own, on its own. The other thing about why this question is hard is part 3, which is, you see this idea of greatest and least value of a certain probability, okay? Well, of course, it's not a lame answer question like, you know, oh, it must be less than equal to 1 and less than between 0 to 1. That's super lame. You won't get any marks. I think the marks distribution, if I'm not wrong, I think it's 1, 2, 3. Okay, so the last one, 3 marks, obviously is not asking for 0 to 1, right? So there are two things that are quite interesting about this question. So we shall talk about it. Okay. All right. Let's read through. All right. So you have event A, B, C, which is given like that, and then A intersect B intersect C is given. All right. So A and B are independent. Okay. So these are the little bits and pieces of information that we know. A and C are independent. So find B given A. This is only 1 mark. So thank goodness for that, because it's actually pretty easy. I think we talked about this a few times during lesson 1 as well, right? Lesson 1 on probability. We talk about it like when we have conditional probability, whereby the events are actually independent. So according to this formula, right? Okay, so this is PB first, then times PA, because they are independent. So the intersection will be the product, which is not hard to understand, right? So then therefore you just simply get PB, which is 0.4. So it's a 1 mark kind of question whereby I think you don't have to write that much to get the 1 mark. Just write 0.4, you get a 1 mark anyway. So it's pretty easy. If you know it, you know it. If you don't know it, you probably go a long way to find it anyway. Okay, so it's all right. Part 2 is one of the scary things that I was telling you about. Okay, event B and C are also independent. Now, what does this add on? Well, not much really, but except now we know that the B intersects C we can find, right? So we can just take the product of the B and C, and then we can get the B intersects C. That's all we know. Now then, we want to find this. Now, what the heck is this? Now, some people will start thinking like this, which is a very common, I'm quite sure on that year, 2015, I'm quite sure quite a handful of students actually did it this way. A and B are independent, right? So A prime, B prime are independent also, right? Okay. A and C are independent, right? So A prime, C prime is also independent, right? So B and C are also independent, right? So B prime, C prime also independent, right? So that sounds like A, B, C all independent, right? Correct. So if A, B, C are independent, then this is simply just A prime times B prime times C prime, right? Correct? Then I take 1 minus this, times 1 minus this, times 1 minus this. I get the answer? 2 marks. You think so simple? That's wrong. Okay? So this is wrong. Now what's wrong? Now this is not so obvious. And again, before 2015, probably a lot of teachers never mentioned that as well, because you don't have a lot of questions like this. So what's wrong with this? 2 reasons. All right, the first one is more theoretical and therefore more difficult to think, is that A and B are independent, what they call pairwise independent. So A and B are independent, so you can find A intersect B. So that's pretty okay. A and C are independent. B and C are independent. They're all pairwise independent. It doesn't mean all 3 of them must be independent. So that is the correct reasoning. Okay, so A, B independent with each other, yeah, but it doesn't mean that A, B, C are all independent with each other. Okay, so that reasoning is not well discussed in school or anywhere else, because hardly have this kind of experience really. Okay, the other way you can actually try to test your theory, okay, in exam. Thankfully, we were actually given this. Okay, we were given the A intersect B intersect C. So if in some sense, I mean, you never heard of the term pairwise independence, then of course you won't be able to logic it out like that, right? So thank goodness we still have another way, which is the second way, to figure out whether our theory, this idea works or not. Turns out it doesn't work, because if it works, if A, B, C are independent, then A intersect B intersect C should be this times this times this, which you realize can't be giving you 0.1, right? Yeah. So that realization tells you that, well, it can't be so simple. Okay? Can? All right. So there are a few of all these misconceptions that I'm quite sure it happens to quite a handful of students, because honestly, when you're quite desperate, you don't know what to do, you come up with something, and then you try, right? That's what I always advise you guys. Just try, write something better than blank. But anyway, this one, you write something that's completely wrong, you get 0 anyway, so it's as good as blank, okay? So how do we deal about this? How do we go about dealing with this? Okay, turns out, obviously it's a set question. So you already know the trick is Mickey Mouse, right? So let's take a look at the Mickey Mouse. So we have 3 circles, and that's why the shape of a Mickey Mouse like this, right? So A prime intersect B prime intersect C prime literally talks about the area outside the Mickey Mouse, which is, well, right here. So the question is, how do I find the area outside the Mickey Mouse? And it turns out, if you know how to find the A union B union C, which is the so-called the Mickey Mouse, then you take 1 minus, you are done. And that is actually one of the problems, because it turns out that not many students know how to deal with the Mickey Mouse. Right? So we all understand this, right? This is like A union B union C. Okay, and the problem with, like I mentioned before, this Mickey Mouse was quite unheard of before 2015. So it's like, oh, okay, great. And some people try to think about it in the sense that, okay, I know how to find peanut, right? The peanut, which is the A union B. So it must be the same idea. It turns out it's actually a bit more tricky. Remember day 1 we talked about it? It's a bit more tricky than that. Right? So, but it turns out it works very well if you know it. So that's the problem with this question, if you know it. So it's actually the whole of A plus the whole of B plus the whole of C. But you know that you double counted quite a fair bit. So you must minus away the A intersect B, minus away the A intersect C, minus away the B intersect C, of which all these intersections you can find because they're all pairwise independents. So we all are fine, except that you realize that you minus away all the overlaps, you peel off 3 times, then the middle portion is now empty. So you need to add back the middle portion. So even this Mickey Mouse formula, if you are quite unfamiliar, to be honest, if you think of this yourself, it probably take a while. Because when you have a peanut, and with 2 circles, right? Yeah, what I like to call peanut. Okay, when you have peanut, it's a lot easier because you think in terms of tissue paper like that, you know, 1 layer, another layer. So you have a blue layer, which is the A, and then you have a red area, which is the B. So when you overlap them, you double counted which part? This part, right? So you just have to peel off 1 time, done. Okay, but this one is a bit more complex, right? Because you peel off, yes, you peel off, then the middle portion you actually peel off 3 times. So it turns out the middle portion now become empty. So you got to patch it back. So it's a bit more challenging in that sense. Not that you can't think of this yourself. You probably take a while. Okay? Unless, of course, you know the formula, which is quite unlikely because, like I mentioned, not many people actually use this formula before 2015. Alright, so after that, we have all the information we need. We will be able to find the answer. Okay? So, how am I going to write this? Okay, so it's 0.45. So 1 minus away, 0.45 plus, I think it was 0.4, right? 0.4 plus 0.3 minus of, hold on, okay, 0.4, 0.3, okay, good. So all this information I need, that's all. All right, A intersect B will be 0.45 times 0.4, all right, and then A intersect C will be 0.45 times 0.3, and then B intersect C is 0.4 times 0.3, and then plus 0.1. Okay, so all this adds up. We should be able to get the answer. What's the answer? 0.185, right? Yeah, I think so. Okay, so I was just doing it, and we get the answer. Okay, so if you know the Mickey Mouse, it's actually not that hard. The problem is, well, not that many people actually know it quite well. Okay, okay. All right, so let's move on to the next difficulty about this question. All right, which is the part 3, right? Given instead that now B and C are not independent. Suddenly now they are not independent. So what difference does it make? Only one thing, right? And that you know that when they are not independent, then the B intersect C, you don't know. Because it's no longer B times C anymore, right? To give you the B intersect. So that is the only thing that has changed for this part. Find the greatest and the least possible value of this. Isn't this the same probability that you just found? which is outside the Mickey Mouse. So it turns out that, okay, this shaded part is no longer 0.185. It is now changeable, a variable now, right? It can vary from big to small. How do you think it can vary? There's only one way, right? The Mickey Mouse vary itself, lah. Correct? So the idea is the Mickey Mouse, the unshaded part, actually can change. So you think hard enough, you go like, okay, not that hard to understand, but you probably guess that, okay, let's start off with, I want the minimum value. Okay, let's talk about minimum first. Okay, so if I want to find the minimum unshaded part, okay, maybe I start here. Okay, minimum unshaded part. So what do you think I hope for? Well, you hope that the, minimum shaded part, sorry. Then I hope for the unshaded part to take up as much space as possible. Am I right? So you hope that, hey, if possible, they look like this. So that they take up as much space as possible, then my shaded part will be as small as possible. Okay. So what is A? A is 0.45. What is B? B is 0.4. What is C? C is 0.3. You realize it's impossible because add all more than 1, right? So you got a great. There must be some overlaps. Now, on closer analysis, then you realize that, wait a minute, actually, you cannot be like this as well because A and B are still independent one. So they are still going to overlap. A and C are still independent, so they are still going to overlap. So obviously, it cannot be like this, right? 3 separate circles. So in some sense, there are a lot of things that we actually calculated here that are still the same. The only thing that is now different is the B intersect C, which I think, yeah, this is the number, right? This is a B intersect C. That is the number, the only thing that can change. Or rather, that we don't know now. Okay? Everything else is actually still fixed, no? Okay? So now we think about it, we're like, okay, great. Now, I still have my Mickey Mouse, right? Okay, so I probably draw another Mickey Mouse. And I look at it. I go, okay, great. Now, A, B, largely the same. Nothing changes about A and B. The only thing that is actually unknown is actually this part. So if you think about it, this is the only part that can vary now. Everything else is fixed. Correct or not? Now, in some sense, if you think about it, you're like, wait a minute. Now, you see that you actually have a peanut. This peanut is still fixed. It's still the A plus the B minus the weight intersect B, right? There's no change. So maybe we can start off by calculating how much this area takes up. Okay? So this area, which is the A union B, okay, will be, of course, the A plus the B minus of 1 time of it, right? So this one times this one. Okay? I believe it's 0.67 if my memory doesn't fail me. So if you have calculator, please help me. You know what? I should fish out my own. Okay. Yeah. Okay? In case the numbers are wrong, that would be very troubling because later I have to troubleshoot. Yeah, 0.67. Okay, that's cool. Alright, so this peanut here is 0.67. It's fixed. There's nothing you can do about it. Okay, what else? Now, then we understand that, okay, hold on now. Some things about C is still fixed. Like, for example, the whole C is still going to be 0.3. There's no way you can do anything about it, right? So let's think, guys. If I want to maximize my unshaded part, which is the inside of the Mickey Mouse, what do you think you want to happen to the red color part? Well, you actually want to push the circle out as much as possible, right? Knowing that this still must be 0.1, right? It still must be there. This whole thing, it still must be 0.4 times 0.1. 0.45 times 0.3 must still be there, right? But the whole idea is that the red color part is the only part you can actually squeeze, right? So if you want it to be taking as much space as possible, you try to squeeze it out so that the red color becomes 0, if possible. So how do you think we can do that? Well, it turns out that because the whole blue circle is 0.3, and we also know that this overlap is fixed. This overlap turns out to be A times C, right, which is this magic number here. 0.45 times 0.3. Okay, I have no idea what is this. Can we just use calculator, right? 0.45 times 0.3, so that gives me 0.135. So this blue color shaded part is fixed. Now, the whole circle is 0.3, and if this blue color part is 0.135, which is fixed, if I want to make the red one 0, Therefore, this must be the 0.3 minus away 0.135. That gives you, hold on, 0.3 minus 0.135, 0.165. So if this portion here is a 0.165, then effectively the red color part is 0. Make sense? Because as long as the 0.165 plus the 0.135, which are all fixed, becomes 0.3, then the red color part must be 0. Okay. Now the problem with this is that is a circular Venn diagram that we are quite used to, and we go like, Mr. Tang, I'm quite lost, because I can't visualize how it looks like. So which is a fair thing. All right. So let me show you another way you can try to draw a Venn diagram in a way that represent this in a bit more accurate manner. Okay. So instead of drawing your sets as a circular shape, you could have drawn it in a rectangular shape, really. Okay. So this is your A, this is your B. So the whole rectangle is your A union B. Right. So this whole A union B is your 0.67, which is still largely the same. Now for your C, you want to make sure that the B doesn't touch C, then this is how it should look like. Okay, so that's your set C. And what we just realized was that this is your A intersect C, which turns out to be your 135. And this whole blue square rectangle must be 0.3, so that makes this part, 0.165. So therefore, there's no red part at all. Right, which is now effectively 0. So, I mean, some people see this, they have problem trying to relate, because the red part is there, you tell me it's 0, I cannot imagine. But I mean, some people can, that's fine. But this is another approach to handle what we are so used to, circular shapes. Understand? So now that we get all the necessary things up, so bear in mind what our job is to find the shaded part outside, Okay? So the whole, all in all, this whole Mickey Mouse will be taking up 0.67 plus 0.165. Make sense? So therefore, we actually solve our problem, right? Our minimum A prime intersect B prime intersect C prime will be 1 minus away the 0.67 minus, plus 0.165. Okay? Then I believe the answer, if I'm not wrong, is 0.165 as well, right? So, just to make sure. Yep. Okay? Understand or not? Alright, but that's not the end of it. I'm not completely out of the woods. But definitely this will help you a lot, because the moment you are quite certain about this, the maximum is just about the reverse. Okay? Now, let's think about the maximum now. I'll probably go to another page. Okay, so maximum of the, what we call the shaded part. So if you think about it, right, this is your Mickey Mouse, and you want the shaded part to be maximized. What do you think you want to happen? You want the unshaded part to be minimized. Agree? So you want the Mickey Mouse now to take up as small a space as possible. Agree? Okay, what is the dream come true? Well, the best to happen is this, right? Correct. I mean, take out the three circle, take out the least space possible, right? But you realize this is not possible. Why? Because A and B are still independent. So the peanut is still there, right? The A union B is still there. So like what we discussed before, the A union B, the 0.67 is still there. The A intersect C is still going to be there. So we know that this is our dream, but our dream can't come true. Okay? Okay, so forget it. So, let's think harder. Okay, so what we understand is that a few things are still fixed. A and B are still independent, so we understand that this is AB. So this entire peanut, as we know it, is still 0.67. Okay, so that's pretty much alright. Again, if we go back to our analysis here, is the red color part that is moving yet again, right? It's the only thing that we can change. Previously, we tried to make it into 0 so that we are trying to push the blue color circle out as much as possible. Right now, what you want the red color part to be is to be as big as possible. Now think again, guys. This blue color part is fixed, which is your 0.135. There's nothing you can do about it, right? Because the A still must overlap with C. But the red color part is the one that can vary now. So what do you think you can do? How do we make this grow? Well, instead of pushing the circle out, now we push it back in, right? Correct. So I push the circle back in as much as possible so that, in fact, this part You want to make it 0. Agree? So that everything can be pushed into the red color part, and then the red color part grows bigger. Because the whole circle still must be fixed at 0.3. Get the idea? Okay. So now we think and you probably think about how to draw this diagram, right? It's going to look a bit like this. That's how a C is supposed to look like. Okay? So you just imagine a bit of imagination. Push this whole thing up, and it looks like this. Okay? So the red part, if you're wondering, is right here. And there's no more outside anymore. Right? All the outside has been pushed up. All right? And this is the part that, what is that? 0.135, right? This is the fixed one that we can't change. Okay? Which is the A intersect C. And it's still there. Okay? You may want to do a quick check for housekeeping's sake, because if you think about it, right, this is 0.135 as what we calculated here. Okay? And now the way we drew it is actually inside the A intersect B. So your A intersect B better be greater than 0.135. Alright? Otherwise the diagram again doesn't make sense. But then again, usually it's fine, because at most you draw it a little bit outer or whatever. That should be okay. But the whole idea is this is the idea. Okay? So therefore, you realize that the C doesn't take out any space at all. So the entire peanut is the space that's being taken up by this so-called Mickey Mouse, the deformed Mickey Mouse. Alright, so therefore your maximum will be, well, 1 minus 0.67. I think that gives you 0.33. Okay, so that's the maximum minimum for this. Are we all clear? Can? Now, I don't know how much you know about your TYS, but I believe if you look through a TYS for the past 10 years or maybe even the 15 years, this is the second time it came out. Okay, this maximum minimum type of question, second time. But this is the only time that it comes out with the 3 circle one. The first time it came out, I can't remember what year, but that one wasn't a very impressive question. I can't remember what was the gist of it. But anyway, it was something like this, but also asking for maximum minimum. Okay, but I think that one is a bit more, it wasn't a lot of drawings, but I can't remember what is it, but we can find out. Okay, Ken? Alright, so this question is kind of scary. 2015, like I told you, not like 20 years ago, it's just a couple of years ago. So that is the standard of what A-level is like as well. Okay, can be quite scary, yeah? Alright, any questions? Okay, very good. Come, let's